All right, so now we've got another property of integrals question. You'll notice this calculator is okay, but that wouldn't be really helpful, would it? Because these are all, this is just more about expressions. It says f and g are continuous functions in the interval a to b. A is less than c is less than b. I just kind of wrote that bigger because I'm going to make a comment about that. You have the integral from a to b of f equaling p. The integral from c to b, I'm just trying to write these a little bigger, of f is q, etc. Info about f and g with those numbers a, b, and c. We have to find the integral from a to c of f minus g. So the first thing I would do is just, because all the info about integrals are about the functions individually, you should use a property right away. That would be that this is going to be the integral from a to c of f. I'm just going to abuse notation a little bit because it's just a multiple choice. And then we're going to minus the integral from a to c of g. That's a property. You can you can split them into two integrals. So then we're going to find this, and then we're going to find this, and we're going to subtract, and we're just going to get an expression. Now, so let's deal with the green, the integral from a to c of f. Okay, now this is where I'm going to write something. So this is this info is irrelevant. That's an important thing to note. I don't even look at this. It doesn't matter how a, b, and c relate to each other. You can use this property I'm about to write down, which is that, okay, we want the integral from a to c. So I need to start this integral at a, and I need to end the next one at c. Okay, so notice I'm adding. This is fine. And then the thing in between, of course, is a b, because that's the other letter involved. It doesn't matter that, I mean, I know this makes it look like b is in between a and c, but it doesn't matter how all of these relate to one another. This property of integrals is powerful enough to work no matter what. So all you focus on is that these match. Okay, this needs to match with this. And of course, your a and your c need to give us what we want over in our original integral. Okay, so we're going to do that, and then we're going to minus. Okay, we're going to minus, we'll keep that in mind. We're going to minus the integral from a to c of g. And again, same thing. I can do this. A, c, and as long as these are both b's, this property will work. All right? So that's why I say that inequality up there is irrelevant. Let's be mindful. We're going to have to distribute. Like, we're going to get two expressions. This is going to have to distribute to those two values. So just keep that in mind. Okay, so let's go look. So the integral from a to b of f, they told us that directly. That's just p. So this is p plus the integral from b to c of f. So they didn't give us that directly. They gave us the integral from c to b. Notice those are reversed. But I wouldn't write anything. This could be done mentally. If you flip the limits of integration, if you just flip these limits of integration, you can just negate the value down here. Okay, so like that will become a negative q. So this is negative q. So that part's done. Now let's go down to g. Integral from a to b. They told us that's r. That's directly given information. And then plus, and then the integral from, again, same thing. They gave us the integral from c to b. We want the integral from b to c. So just flip these, and then that'll become a negative s. Now, there's still room for error here, because look carefully what you're doing. You're going to do p minus q, okay, minus the expression r minus s, which means it's p minus q minus r plus s. And I think that's answer choice B.